We are studying the first chapter, Relations and Functions. Today's topic is Types of Functions. Number 1, one-to-one function. A function f from a to b is called a one-to-one function if distinct elements of a has distinct images in b. It is also called an injection. So here, for example, let us take set a is equal to 1, 2, 3, b is equal to abc. So here under function f, the image of 1 is a. So let us write down the ordered pair 1 comma a. Image of 2 is b. So 2 comma b. 3, the image is c. So here you can see that distinct elements of a has got distinct images. So it is an one-to-one function. Okay, here a is called the image of 1 under f, or you can even call 1 as the pre-image of a. Okay, 2 is called the pre-image of b. So this you can keep it in mind because these terms will come in the exercise. Okay, number 2 is many-one function. A function is called many-one function if 2 or more elements of a has the same image in b. So for example, let us take again the same example 1, 2, 3, b is equal to abc. Now under function g, the image of 1 is a and the image of 2 also is a. Okay, the image of 3 is c. Now this function g, it has got the same image for 2 elements of a, 2 different elements of a. So this is not a one-to-one function, it is called a many-to-one function. Onto function. A function f from a to b is called an onto function if the range of f is equal to the codomain b of f. It is also called a surjection. If the function is one-to-one and onto, then it is called a bijection. So one-to-one function is called an injection, an onto function is called a surjection, and if both the conditions are satisfied, it is called a bijection. Okay, for onto function, the condition is that the range should be equal to the codomain. Very simple. So here you can see that if this is the domain, this is the codomain, and this is the function. I'm mapping 1 to 1 to a, 2 to b, 3 to c, like this. Then you can see that the range is a comma b comma c, which is the same as the codomain. So this is an onto function or an surjection. Into function, a function is called an into function if there exists at least one element in b which is not the image of any element of a. So for example, this is a and this is b. So here the first ordered pair is 1a, 2b, 3c. Okay, and here there are 2 more elements d and e which does not have any pre-image in a. Therefore, this is an into function. That means this range of this g, a, b and c is not equal to the codomain b. Okay, all this will become very clear when we do problem sums. Don't worry, just that these are the definitions of these 4 different kinds of functions. Okay, there are special cases of functions also. Let us look what they are. Number 1 is constant function. A function f from a to b is called a constant function if the range of f contains only one element. So the range has got only one element, then it's a constant function. Identity function, if a be a non-empty set, then the function f from a to a defined by fx is equal to x for all x belonging to a is called an identity function. So this function, identity function, is from a to a. Okay, so let the set be a. This is 1, 2, 3. Identity function, we denote it as ia is equal to, so here the element is 1, the image also is 1. Second, the element is 2, the image is also 2. It is a function from a to a. 3, the image is also 3. This is called an identity function. Real valued function, a function f from a to b is called real valued function the range of f is a subset of R. Okay, R is the set of real numbers. Representation of a function. A function may be represented by a set of ordered pairs. We have seen that a table form, an arrow diagram, or a graph. 4 different ways to represent a graph. Okay, in a graph there is another 2 rules. One is the vertical line test. A curve drawn in a graph represents a function if every vertical line intersects the curve at only one point. Okay, we'll see the exercise sum on this. Horizontal line test, a function represented in a graph is 1 to 1 if every horizontal line intersects the curve at only one point. Okay, let us go to the exercise. So all these definitions will be more clear. Exercise 1.4, question 1. Determine whether the graph given below represents function. If give reason for your answers concerning each graph. So this is the graph, this curve, this is the x-axis, this is the y-axis. So we have to find out if this curve is a function. Draw a vertical line like this. This dot 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 is the vertical line I've drawn. You can see that it intersects the curve in 2 points. This is one point, this is another point. So it is not a function. Okay, second graph, you can see the curve of the graph goes like this. This is the x-axis, this is the y-axis. I'm drawing this vertical line, this dot dot line like this. Vertical it should be. It intersects the curve at only in one point. So it is a function. Draw any vertical line anywhere in the curve. It will intersect at only one point. Okay, it is a function. Next is this curve in the form of S. X-axis, y-axis. Draw a vertical line anywhere in the curve. You can see that it will intersect in 3 points. 1 point, 2 point, 3rd point. So it is not a function. Fourth one is this line. Draw any vertical line. Only one point will be the point of intersection. So it is a function. Question 2. Let f from a to b be a function defined by fx is equal to x upon 2 minus 1, where a is equal to 2, 4, 6, 10, 12, b is equal to 0, 1, 2, 4, 5, 9. Represent f by a set of ordered pairs, a table, an arrow diagram, and a graph. So let us write down the two sets a and b. Write down the function. Okay, now take this first element from set a, which will be the domain. Okay, so substitute here x, find the value. So f at 2, the image will be 0. F at 4, substitute, you get the image as 1. F at 6, you get it as 2. F at 10 as 4. F at 12 as 5. So here, these are the images. So write down the set. They're asking us to first write down the set as ordered pairs. So write down the ordered pairs. 2, 0, 4, 1, 6, 2, 10, 4, and 12, 5. So this was the set of ordered pairs. Now as a table. So write down all the x values here and then write down the fx values. So the x values will be this domain 2, 4, 6, 10, 12, and fx values we found out. Write down those values. This is in the form of a table. Arrow diagram, write down the domain A, the codomain B, and then you have to map it to the image. 2 had the image 0, 4 had image 1, 6, 2, 10, 4, and 12, 5, like this. So this is the arrow diagram. And graph, you know, it's very easy. So this is the x-axis, this is the y-axis. Take the graph paper, draw the x-axis, y-axis, then plot the points. So the first ordered pair was 2, 0. So 2 was the x-coordinate and the y-coordinate or the fx will be the y-axis. Okay, remember fx. This is x and this is fx or y also you can say. So here it is. So when x is 2, the fx is 0. So this is the point. When x is 4, fx is 1. This is the point. 6, fx is 2. When x is 10, fx is 4, x is 12, fx is 5. So these are the different points. Question 3. Represent the function f, the ordered pairs. They have given the function as an ordered pairs. 1, 2, 2, 2, 3, 2, 4, 3, 5, 4. Through an arrow diagram, a table form and a graph. So here we have to first draw the arrow diagram. So write down. So what is the domain? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, write down the domain. And then the codomain. So here it is 2, 2, 2. Do not repeat. 2, 3, 4. So 2, 3, 4. Okay. The image of 1 is 2. So draw this arrow. Image of 2 also is 2. This is another arrow. Image of 3 is 2. The third arrow. Image of 4 is 3. Image of 5 is 4. So this is a many one function. Okay. Write down in table form x and fx. Okay, you can keep the table as a vertical table like this or also as a horizontal, whatever your teacher tells you to do, you can do. So here it is, x is 1, 2, 3, 4, 5. These are the values of x and this is the values of fx. So 1 image is 2, 2, 2, 4 the image is 3, 5 the image is 4. So write down the table. And to draw the graph also is very easy. Take the graph paper, draw the x-axis, the y-axis, plot the points 1, 2. 1, 2. This is the first point. Second is 2, 2. So this is 2, this is 2, this is the next one. 3, 2. So 3 and 2. Then 4, 3. 4, 3 is here. 5, 4 is here. This is the points. You can join them with the line. So here we come to the end of this video. I have done sums from question 1 to question 3. The next video we will do the remaining sums.